Hi, Spring fans. Today, the Spring AI M6 release just dropped, and this is not just the version of the Apple Silicon chip that I want to have. This is actually one of the most impactful releases of Spring AI, which is itself, remember, not even yet 1.0, and it's got just tons and tons of features that put it on par with any other toolkit out there, if not ahead of the pack, as we'll see today. One of the key features introduced in M6 that we sort of previewed as a sort of an experimental extension that lived in a separate repository back in November was initial support for the then nascent MCP protocol, Model Context Protocol. This was developed by Anthropic, the makers of Claude.ai. It's a desktop, it's an LLM just like ChatGPT that you can use from a desktop client like Claude Desktop or from the web. And the model itself is really, really good with code and these sorts of things. So you might have even already used it if you've downloaded Visual Studio Code clones like Cursor, which integrate it. It's really, really powerful, and people are doing amazing things with it. One of the key things that's so powerful about MCP, this protocol, is that it's meant to integrate with your model. It's meant to provide new tools to teach your old model new tricks and to give it the ability to sort of incorporate these. Well, we developed initial Java and Spring support for both building client and services based on MCP. And today, we're happy to announce that as of the release of Spring AI M6, which dropped today, Anthropic is officially including the code that we built as the official Java SDK for MCP. So if you're building anything with MCP, you're going to be using the code that we developed. And of course, in Spring AI, we take that support a bit further by building out auto configurations and the sort. So today, we're going to take a look at, how to use MCP. It's worth noting that, of course, there's the Model Context Protocol IO website. Lots of good information here, including information about the Java SDK, which, you'll notice that Christian Solov, core contributor to the Spring AI team, is on here, right? So there you go. And this is the Model Context Protocol GitHub repository, the verified one, the Java SDK. You'll find information about the protocol itself, examples, all that kind of stuff, all here. There's tools you can use to debug it and so on. But what you need to know is that it's a protocol to expose tools, functions, logic, right? As well as a few other things like resources and prompts and so on. I'm not going to get into all of that today. What I really wanted to talk about is how to use MCP in the context of Spring AI. And so we're going to build some software today to do that. There's also a whole host of different servers out there, right? So if I go to Google, this one, for example, Model Context Protocol servers, and then I go down this list, you can see we've got different servers out there already that you can use that do everything from GitLab, GitHub, Google Drive, Git, file systems, fetching, Brave, search, Slack integration, Time, Sentry, IBM stuff, Neo4j, your MySQLs and NoSQLs and all that, Stripe, all this kind of stuff, all these different plugins that support this protocol. So it's grown far beyond its original Claude specific sort of beginnings, and it's become this general purpose way to teach a model new tricks. Now, I hope to see further and further adoption across the industry, but it's already very useful right now if you support it in your application development framework. And it doesn't require you to use Claude as your model. So it can be used in cooperation with that model. So let's go ahead and take a look at building a simple MCP client first and foremost. We're going to go, as always, to start.spring.io. We'll build a new service here. I'm going to call this client because, again, I'm just really good with names. The usual stuff. I'll bring in the web stuff. I'll bring in GraalVM, and I'll bring in OpenAI. Again, it doesn't matter which model you use, as long as you have something that you're happy with. Okay. And at the moment, as I record this, there are no checkboxes here in start.spring.io, but of course, I expect that'll change sooner rather than later. The first thing you want to do is to look at what it looks like to teach your model new tricks without MCP support. Remember, we originally talked about function calling in the earliest versions of Spring AI. In the last year, that's been refactored into something called tools, and that's more in line with industry norms anyway. So it's quite a nice move. And remember, Spring AI is not even 1.0 yet. So let's create a very simple Spring application that uses a model to ask questions about our local file system. Okay, so we're going to answer questions rather about our local file system. So local tools, I guess we'll just call this auto configuration. Okay, and we're going to create we need to give our chat client, which is what we use to talk to our model, tools by which it can answer these questions. Remember, LLM models they have a cutoff date, and after that point, they no longer have fresh information. And even if they have fresh information, they may not have local context specific information. So you can give them these tools to enable that. So I'm going to give them a function that it can use to answer questions about our local machine here. This is a silly example, but I use this because you don't require any API keys. It doesn't require any installation beyond having a file system, a Unix file system. So I expect that you'll be able to run this in your local machines, and it'll sort of demonstrate the point. Okay, but what I do here, I'm doing as a sort of a proxy for anything you can imagine wanting to teach your LLM or your model how to work with. Okay, so we need a way to run some code that will work with the chat client and answer some questions. So let's go ahead and build that out, and we'll just reuse this for our demos today. So named MCP client runner implements application runner, and it's going to be being named. Okay, implement all that, and we're going to have private final atomic reference string bean name. And so we'll say this dot bean name dot set, and then here we're going to have a prompt. I'm going to say prompt equals what files are in the user. So we're going to have a directory on my desktop called user context folder, and of those files which have a name that corresponds to a Chinese greeting. Okay, and so if you look at my folder here, if I open this up, if I look at that, I've got user context. Okay, and I've got hi, hola, ni hao, and salut, and these are hello basically in 4 different languages. So I'm going to need a little intelligence to understand Chinese first of all, and to understand that this is sort of the romanization without the accents of 2 words in Chinese, ni, which is you, and hao, which is good, and which is the idiomatic way of saying are you okay, or how are you, or whatever. And so we're going to answer that. We need a little AI to answer that question, but we also need to be able to access this file in the file system, right? So that's where our little plugin, our extensions, our tools will come in quite handy. So we can answer the question as a string, I suppose, but I really don't want to do that. I want to have a smart response. So maybe I'll create a typed entity here, and I'll call it Chinese file string file name, and then string Chinese word. Okay, so we're going to give it a typed, or maybe just call it word. I don't know, whatever. Give it a typed entity that it can use to give us a response. And finally, we need a pointer to a chat client. Okay, so we'll say private final chat client dot builder. Okay, we'll add that to the constructor, and I'll say builder dot build dot prompt, passing in the prompt. Here we are. And if I was a good engineer, maybe I would take advantage of some of the amazing features in Java these days, including multi-line strings. There we go. Okay, so prompt and dot call, and I'll ask for the entity to come back as this Chinese file dot class. Okay, so there we go, and I just want to print that out. So we're going to say this dot bean name dot get, and there's the response. Yeah. Okay, so let's try it out. We'll register a bean of this type, passing in what is required for this to work. So named MCP client runner, and we'll do a simple one without MCP actually, right? So named, it's going to be an MCP client runner eventually, but right now there's no MCP involved. It's just local functions and so on. So let's go ahead and define this very first one here. Bean named MCP client runner, and we're going to inject the builder, of course, and we're going to inject some tools, right? We're going to export some tools here the old-fashioned way. So static class tools at component, and we'll create at tool. Okay, we need to actually add the starter for this as well. So let's go ahead and add our first AI starter. We need OpenAI, but that's not always the case. So I'll leave that there, and then I'm going to add the AI MCP support. So Spring AI MCP client Spring Boot starter. Okay, so I'll add that, and we have to change our version to use M6 because that again hasn't been updated on the Spring Initializer just yet. So you can see it, there it is, Spring AI M6 in Maven Central. And we're going to say at tool, and we'll have a little method here. So string list files, okay, return, and I mean, it's not hard, right? I'll even create a static string just to make this less tedious. So string file, folder equals, and it'll be users, JLong desktop user context. Yeah. Okay. And we'll say new file and that one. Okay. Pretty straightforward. Easy, easy, easy. And we need to give this a name. It's going to have a name inferred by the name of the method, of course. We'll give it a description, returns all the files in a folder called, and we'll just pass it into client application.folder. Okay, there we go. That should be it. And we can actually, let's just call this printing out, returning the files from folder. All right, pretty straightforward. Let's just do that. Here we go. Okay. And finally, we need to tell our chat client to consult these functions if it determines that it needs to. So again, we're going to send this request to OpenAI, and it's going to say, oh, okay, well, I need to look at a folder. How do I do that? What tools do I have available to me? What functions can I call back? We're going to say, oh, well, you do actually have some functions you can call back. That's what we're going to configure here. So we'll say, builder.default tools. And then we're going to say, we want to just point it to the config class, don't we? So that'll be this tools there. And again, I'm just injecting another Spring Bean. It could be called whatever. It could be called my service, my file service, or whatever you want, right? I'm just pointing it to this thing with the Spring component annotations. And I think that's it. Let's go ahead and try that out. What do you think? Okay, it says returning the files from this directory. And sure enough, it found the file called Nihao, and it even understood that that is the sort of anglified, romanized, whatever, mispronunciation really of these Chinese characters, which is ni and hao. It's actually 2 words. Okay, great. So it's worked, right? We've actually taught our model some tricks. We did it using the Spring component model and Spring AI. Worked a charm, but that business logic lives here, right? And it's inside this Java code, which is fine, but it's very hard to promote sort of the reuse that we're trying to get here. So let's see if we can make this a little bit more elegant. What do you think? Get rid of that. Okay, I'm going to start again. And this time we'll build a configuration class, and we're going to point to a MCP server. And that server will be using the standard IO protocol based implementation for MCP. So there's 2 supported protocols: standard input and output, right? Basically the command line, standard out and standard in. The servers the client and the server can communicate with each other via standard out and standard in on the same host, on the same machine, right? And if you want your service to exist over the network, then you can use HTTP. For now, most of these implementations use standard input and output. So we'll say third-party configuration, and we're going to build an MCP sync client. Okay. And that client, in order to do its work, is going to need the directory that we want. So home, desktop, user context, file, root, okay, return, and we'll need to return a MCP client. So I'll say MCP, okay, and we'll say standard IO parameters is equal to server parameters dot builder. I'm going to use it to tell Node on my local machine to then run this third-party MCP implementation, right? So model, context protocol, okay, server, file system, and we'll give it the name of the directory, so root.getAbsolutePath, and then build. Okay, there's the information, and now we build the client itself, so MCP client dot sync, great, and we want new standard IO client transport. Okay, pass that in. Build that, and maybe we have the REST request timeout. You can do all sorts of other stuff here, but of minutes 1. I mean, you don't, if it takes more than a minute to list the content of a directory, then you've got real problems here, right? But whatever. Okay, moving on. There's that. Okay, so I've got this MCP client. Now I want to create the runner, don't I? So named MCP client runner, passing the builder, and now the MCP sync client as well. Okay, inject that, and we'll say new named MCP client runner, passing in builder.default tools, and we're going to provide a callback rather. So var tools equals new sync MCP tool callback provider, MCP sync client, pass that in there, tools, and there, right? So basically the same stuff as before. We're telling it to point to this MCP sync client. This MCP sync client in turn is connecting to a server, which it happens to start up in the same, it's forking a process, it's shelling out basically, but then that server is what we're connecting to via standard in and standard out. And we're able to use that to then tell our runner, or to tell our chat client how to get information about tools. So let's go ahead and see if that works. Okay, it's worked. It's able to find the directory, on my local machine, find the file, and give us basically the same response. Neat, right? We're reusing somebody else's business logic. I mean, this is a pretty trivial example, obviously, but the point is you can see the potential here, right? I'm reusing functionality. This is like, SOA or microservices, right? We're getting reuse here, right? I think it's more like SOA. And one of the things I love about MCP is that, this feels like the SOA that we always dreamed of, right? It's pain-free. And some of the hardest parts of SOA, because remember, microservices are SOA with the goal of agility, right? It's not a technical discussion, it's an organizational one. But if what you really want is just pure play network-bound services or just isolated services for reuse, that's SOA. That's service-oriented architecture, right? And so this is service-oriented architecture with AI, and AI is smart enough to do all the integration and plumbing and correlation and aggregation for us. So a lot of the pain, a lot of the nonsense that made and bogged down the original wave around SOA 20 years ago, seems like it's gone here because I just pointed it to that thing and I said, here, talk to it, learn how, figure it out, and it was able to do that. Okay, great. So this is manual. I'm creating a MCP sync client myself, and I'm pointing my code to that, and I'm using it to ask questions. Fine, but I don't want to have to do that all myself. So let's see if we can make things a little bit more automatic with the power of auto configuration. So now configuration class, what did I call it? I don't know what I'll call it. Okay, third party configuration. Here, named MCP client runner. Okay, pass that in. And I'll inject the auto-configured tool callback provider, like so. Default tools provider. And that's basically all of it. I need to tell Spring AI to what it should connect. And we can do that by furnishing a config file. I mentioned that this protocol was born out of Anthropic and the Cloud Desktop experience. Cloud Desktop uses a config file that's in JSON, right? And so we actually have support in Spring AI for reading and loading up and reading and sourcing information about your MCP services from that very same configuration format. So let's config that here. First things first, we'll go over here, create a new file, call this fsconfig.json, and paste all this here. So now what I'm going to do is I'm going to specify this config file. I'm going to say npx -y model context server file system, and then point it to the directory, right? I didn't even do that. Oh, I did do that. I did that last time, right? I'm pretty sure I did. Whatever, I'm going to point it to the file system, and it'll just automatically load this information from this config file rather than me having to explicitly specify as much. I now need to tell Spring AI which config file, which JSON property or JSON config file it should consult. It's called fs-config, isn't it? Okay. Now it's talking automatically, one hopes, to the same MCP server. So Spring AI, by the way, is starting up this, it's running this process for you. It's reading the same config and using Process Builder or something like that to shell out and run that program for you. Good. So far, so good. And the result is that we have a thing to which we can connect via the standard in and standard out protocol and get results, and then use that to inform the response we get back from the client. Okay, so that's a lot better, right? Now we're just reusing existing ones. And you can point this, you can define more than one server, right? This is file system, but there's no reason you couldn't have, foo, and then like that, right? Just be our guest, please. Have as many as you want, right? So now you've got a model and you're teaching it new tricks, and those tricks are in services. Remember, we're using standard out here, standard in, standard out, but you can also use HTTP. So you can actually point your code to 0 to n, different MCP services, and it'll just automatically learn how to talk to them, and you can just interact with them with plain English. See the potential here, see the power, and you can standardize, you can centralize all this. And of course, if it's HTTP, well, we have Spring Security, we have all this stuff you can use to secure it. I mean, we're in a good position. Okay, let's keep going, huh? I think we can still do better. In this case, we reused somebody else's MCP service, and it happens to be standard in, standard out based. Why don't we create one that's using HTTP? And in fact, why don't we create our own? We're going to create a sort of microservice, a service-oriented AI microservice. Do I win buzzword bingo there or no? Yeah, maybe? Okay, so we're going to go ahead and create a new service here, start.spring.io, and I'm just going to call it service because I'm great with names. Okay, same basic thing, but we're not using OpenAI here. Remember, this is just going to be an MCP server. It's not actually using the model at all, but I'm going to use that to force the initializer to set up the build to give us all the stuff that we care about for the bill of materials for Spring AI. Okay, so first things first, same as we did last time, go here, force this up to M6, and then drop the OpenAI model and bring in the, I guess we want the Spring AI MCP server WebMVC Spring Boot starter. So we're going to use Spring MVC. There's also a reactive Webflux variant there if you prefer that stack. And we'll just pull that in. And in the server, this is going to be very straightforward. Obviously, we don't have a whole heck of a lot of complicated business logic here. We'll create a Spring Bean. That file tools, I guess we can call it whatever we please. Call it tool. I'll say description returns all the files in a folder, and I can list the file name. I don't have the constant like we did last time, but you can do that if you wanted to. Okay, so we're going to give it a human readable description there. String list files. Okay, and the same exact thing. Actually, what am I doing? Oh, I deleted the code. Well, whatever. Okay, new file. Okay, and we'll say system. We could do that, couldn't we? But it's fine. Whatever. Okay, so we're going to list the files. There's nothing really special there. We need to tell Spring AI to export that though. So we'll say tool callback provider. It's going to sweep and discover and register these tools. So file system tool provider. Okay. And we'll inject our file tools. New, we'll say method tool callback provider dot builder dot tool objects tools. Yeah. And dot build. There we go. That's the hard part. Now we just need to configure this to start up and run on a separate port, first of all. So port will be 8081. Okay. I suppose that's it. Let's go ahead and start this up. Okay. Now we go back to the client. And here, same as before, we're going to R file system or Bootiful MCP configuration. Okay. Bootiful. Okay. Good. And, same as last time, we want to point it to our service, but this time it's HTTP, isn't it? So bean MCP sync client, MCP sync client, return MCP client dot sync new HTTP client standard transport. Notice how consistent everything is here. Localhost 8081. Okay, and then dot build. And I guess we want to initialize. So var MCP return MCP dot initialize. This class, by the way, the resulting MCP client type, MCP sync client, there's a corresponding async client and async service. Like I indicated before, there's a Webflux version. There's also an async client that you can use for if you want more streaming sort of use cases. And also this implements auto closable, right? So it keeps some state. It keeps potentially some long-lived session, connections rather, to a service up and running. But it'll automatically, when Spring shuts down, it'll automatically go through all the beans in the context. It'll look for all the beans that have a close method and that implement auto closable, and it'll call close on that for you. Okay, I think that's the hard part. And this basically is this the same? We have to provide the MCP sync client. Okay, and here we'll say var MCP tool callback provider equals MCP sync MC. Okay, there we go. Not bad at all. So client, provide that. Good. So we're just going to point, this is so cool. We're just going to point our code to a remote service now with the same abstraction, same interfaces as we used to point it to the local standard in, standard out version. Okay. Failed 404 8081. Is this running on port 8081? Should be, yeah. Did I forget to register something on the server side, I wonder? Or did I forget to use the right dependency on the server side? No, that's correct. Server Spring. Okay, so service, and then we go to the client. Okay. Turns out that / makes a difference. So I'm glad I removed that. Okay, so there you go. We've gotten the file now. So we got the file from remote. Like, let's go ahead and line things up so we can kind of see them both in action, right? So I'll print out calling list files, and we'll restart this. Okay, it's got graceful shutdown. Nice new feature in Spring Boot 3.4 and later. We automatically wait for in and out requests. Go ahead and restart the client now. Okay, you can see calling list files. And as soon as we did that, we get the response on the client. Nice. Now we have a client and a server based on MCP. We're able to centralize our business logic. So now you can point all of your chat clients in your organization to this MCP service, and they can reuse that business logic. Isn't that cool? That's really, really powerful. And of course, again, it's HTTP. So assuming you can figure out how to ferry the right token and username and password or whatever, you can do authentication, you can do proxy, you can do client-side load balancing, you can do all sorts of cool stuff here. Just taking advantage of the rest of the Spring ecosystem. Super, super, super good. Now, I'm using HTTP because to me, for an enterprise context, that makes a lot more sense. And notice that at this point, there is no Claude. I've been using OpenAI plus this MCP service. I haven't used Claude. That's great. But remember, why did Claude create this in the first place? Well, they created this so that people could add plugins, if you will, to the Claude desktop experience. So if you've ever used ChatGPT, you know you can go to ChatGPT on the web. There's also a Mac and Windows client. Well, Claude has basically the same thing. It's a native Windows and Mac application that you install on your computer that when you open it, I think is just a frame around the web experience, but it has the ability to support plugins. And I think it's experimental. I'm not sure, but yeah, I'll refer you to the documentation for that. But the point is, you can install these plugins by modifying a config file and restarting Claude. And that's what I want to do. I want to take our server and then teach Claude to talk to it, right? So we're no longer the client anymore. We're going to let Claude Desktop be the client. So let's go ahead and hide this thing here. We'll open that up again. And we want to build this as a native image. And we also want to take advantage of standard I/O, because if there's one lament I might have, it's that for the instance, for the moment, Claude Desktop doesn't support HTTP. That's right. Anthropic developed the MCP protocol and they put forth the specifications for both HTTP and standard I/O, but at the moment they don't support HTTP. So we have to build an MCP client into MCP service using standard input and output, which begs the question, what if I really did have, some sort of business logic and I wanted to standardize it and centralize it and I don't want to distribute the binary to the client? Well, then you would have to build a MCP client using our MCP client support that in turn talk to an MCP service. So you build a MCP client Spring Boot app, you deploy that to the user machines, that in turn would talk to an MCP service using HTTP, which you can do, right? You can act as a sort of gateway. We need to point Claude Desktop to a binary, and it needs to run it. It needs to be able to run the thing. And obviously, I don't want to tell it how to download the JDK and all that. So this is one of those use cases where GraalVM, again, just coming in super clutch, super useful. So let's turn this code into a standard I/O implementation, first of all. We'll go here, and in order for this to work, we need to disable the logging, and we need to turn off the banner. I know, this hurts me too. And we need to enable the standard I/O support. So by default, you get the HTTP support if you have the HTTP starter in the class path. But you can have both and disable the HTTP stuff, or enable rather the standard I/O stuff. So springai.mcp.server.standard.io equals true. So logging is off, banner is off. Like if I run this again, it's running, but there's no log output, right? That's the whole point. Because remember, the protocol is via standard out. So you can't afford to have those beautiful, beautiful Spring Boot banners because it's not part of the protocol, sadly. So skip tests, native :compile. Okay. So there's our native binary. Look at that service, right? And you've seen this before. This is not a new thing for you. 81 megs. So now we want to tell Claude to use that. So let's open up my Claude desktop. I'm on a Mac, obviously, and so we have to do Claude application support, Claude desktop config.json. Okay, and here we go. That looks no, is that right? That's not right. We need to find out the right directory here. CD service target, and we'll paste that here. Okay, so it's going to be called Beautiful File System. We're going to tell it to run this binary. We're going to save that file. This is in that directory I just showed you. And we'll then start up Claude. Okay, and we'll ask it the same question we've been asking this entire time, which is, what files are in the user context directory, and which file has a name that corresponds to a Mandarin Chinese greeting? Now you can see it's realized that it needs some context. It knows that this Beautiful File System tool can help it answer this question. So it's asking me, do I want to allow it to do that? Very useful, because remember, like this thing is accessing our file system, and now we're letting the AI have full run of the file system. That could be dangerous, right? Hit allow. I'm not sure what this error, unexpected token, no idea, whatever. It gave us the right response, right? Looking at the files, ni hao is the file that corresponds to a Chinese greeting, blah, and the directory contains 4 files total, ni hao, hola, hi, and salut, right? And it even gave us the details on the other files. So clearly, this is a very, very powerful thing, right? And we've just begun to scratch the surface here. This allows you to build, I mean, it's a service, right? You can now reuse services. And I think this is the best version of SOA, the best version of AI, is this ability to automatically wield and combine and aggregate all this functionality to give our model, which is already very, very powerful, access to these tools. The next step beyond that is to then wield our model in the context of some of these agentic workflows, right? To let the model direct its processing, based on a multi-step workflow. And that's you need this to get there. So I'm really excited to have this piece so nicely figured out and ready for you to use as of today. Go get the bits, try it out, and enjoy, as always, your journey to production.